and welcome to this What's New in Siemens NX video. Today we're going to be taking a look at the latest enhancements that integrated structural validation. And to take you through the demo, I'm going to hand over to Jeff.
Follow me along to perform a design analysis so that we can give Paul the feedback that he needs. We will start by loading the optimized part, which is a convergent body, from the server. We will use an application inside of NX called Pre-Post to perform the analysis. We will create 3 files to contain all of the CAE data that we will be generating. The SIM file will store information such as loads and boundary conditions. The FEM file will contain our nodes, elements, and material data. An idealized part is created as a duplicate of the CAD model so that we, as an analyst, can make changes without disrupting the workflow of the designer. Next, we need to assign a material to the part and then generate a 3D mesh. I like to click on the lightning bolt to get an approximation of the recommended mesh size. Don't go any larger than this, as it can make for a poor quality mesh. A reasonably smaller number than the recommended size will give better results without forcing the solution to take too much time. Now we need to create a rigid element with its base node at the approximate location of the center of mass of the gearbox that attaches to this mounting bracket. We don't need to be exact for this analysis, as we are only trying to provide baseline guidance to improve the quality of the design. Use the between 2 points method to get an approximate location. Now that the base node of the rigid element has been created, we will connect it to all 12 of the mounting holes on the bracket. Now we will move on to the simulation to create our boundary conditions and to solve our model. Our boundary conditions consist of constraining the bracket at the 4 mounting locations. The load is applied at the approximated center of gravity of the gearbox. It is meant to imitate a force of 3 times gravitational acceleration in the direction of travel of the vehicle. The mass of the gearbox is used in the magnitude of the force. Solve your model using the integrated SimCenter Nastran solver. This should only take a couple of minutes depending on what kind of computer you are solving on. Now comes the reason for performing the analysis, evaluating the results, and giving recommendations to your CAD designer. When displaying stress results, it is a good idea to turn off any elements that are not needed, clean up the display by turning off element edges, setting the results to average at nodes, and finally changing the scale for effect. Let's interrogate the CAE results so we can make recommendations to Paul. Every structural analysis will indicate the locations of maximum stress with a red color contour. You will see a few areas in the model that have a color red. But we do not need to be concerned, as the overall magnitude of the stress is very low. The results indicate we have a good design that will be able to handle the performance requirements for the part.
Thanks for joining us. In the next video, we're going to be taking a look at model-based definition. We hope you enjoyed this video, and we'll see you in the next one.